How much SQL do you really need for your first data analyst job? If you spend any time on Data Analyst YouTube, you might feel like SQL is this massive thing holding you back from your dream job. But that's not how this actually works. Believe it or not, you need less SQL than you might think, but you do need to know the basics really well. And there's a big difference between those two things. Most junior analysts don't fail because they don't know advanced SQL. They struggle because they don't understand the data they're querying, or they can't even explain why they pulled the data in the first place. In this video, I'm going to show you exactly how much SQL you need for your first data analyst job, what skills actually matter, and what you can safely ignore for now. Basically, I'm going to show you where people waste a ton of time learning things they won't use for years, if ever. So welcome back to my channel, or welcome to my channel if you're new here. My name is Tim. I've spent over a decade working as a data analyst inside Fortune 50 companies, building analyses that actually get used, not just reported and ignored. This channel is about how data analytics work really happens day to day, what skills actually matter, and how to make better career decisions. If that sounds good to you, grab a cup of coffee and stick around. So before we get into it, let's be clear about one thing. SQL still matters a lot. Even if your day-to-day work is in Excel, Tableau, or Power BI, at some point, the data starts in SQL. SQL is how analysts get access to raw data before it's cleaned up, summarized, or wrapped in a pretty dashboard. Most analyst roles aren't about writing complex SQL from scratch. They're about knowing how to ask the database the right question. And that's the part that people miss. You don't need to be a data engineer, but if you can't pull your own data, you're always going to be one step behind, and that means your analytics career isn't going to progress as fast as it should. Before you start looking at some SQL syntax, you need to understand some basics about relational databases. This is where a lot of new analysts skip ahead and end up getting tripped up. Start with basic concepts because these tend to make their way into interview questions. That means knowing the difference between a table and a view. SQL tables are the underlying data asset. That's where the data actually exists. So when you insert, update, or delete data, you're changing what's stored in the tables. By contrast, a SQL view doesn't store data, it stores a query of the data that someone created. Think of it like a saved select statement. As data analysts, we often use views so that we can work more efficiently without worrying about the underlying data structure. Next, you also need to understand what a row actually represents in any given table. Depending on the table, one row might be a customer, or it might be a transaction, or a visit, or an individual product inside a sale. That makes a huge difference when creating reports and dashboards. Because if you think you're counting customers, but you're really counting transactions, your numbers are going to look really impressive and be completely wrong. So when I look at a new data set, I don't start out writing my final query. First, I spend some time exploring, looking at columns, data types, things like that. I try to get an idea of what types of data are there and how the tables relate to each other. That usually involves pulling several small queries to help me understand it better. Once you understand data structures, most of the SQL you use is pretty straightforward. The core of every query is select, from, and where. Select tells you what fields you want to return. From tells the database what table or view you can find them in, and where sets the conditions to filter out everything that doesn't matter for that particular problem. After that, you're usually aggregating. Counts, sums, averages, things like that. That's your group by clause. This is how you turn raw rows into something usable for reporting your dashboard. Order by is used less often, but it's useful for quick checks, things like top 10 customers, largest transactions. It can help you find outliers that look suspicious. If you're comfortable doing all this, then you can answer most day-to-day business questions. This is easily 80% of the SQL I've used throughout my analytics career. Next up is joins, and joins are where most junior analysts start to overcomplicate things. Real-world data lives in multiple tables, so you have to join one table to another. That means you need to understand another basic database concept, and that's primary and foreign keys. A primary key is a unique record in a table. That's what defines that record. For example, a customer table will have a customer ID. Every customer has one ID that uniquely defines them. Foreign keys are how another table points back to that record. That relationship is what makes it a relational database, and you'll join tables based on those keys. So there are several different types of joins. Inner joins and left joins will cover most of what you need to do. Inner joins give you the records that exist in common between both tables. Left joins will give you everything from your main table and pull in matches where they exist from your second table. If you're not sure which one to use, a left join is usually the safer choice for analysts because you can always filter out what you don't need later. Right joins and full outer joins exist, but they're rare. It's good to understand what they do, but you're not going to use them that often. Same thing with union and union all. They're useful in specific situations, but they're not everyday tools. Okay, so you're probably thinking, that's a lot already. So let's pause, take a breath. SQL can get very advanced, and I'll be honest, if you're going to make a career out of data analytics, you will never stop learning SQL. It is that important. But you don't need to master it all at once to get your first data analyst job. Here's some concepts that you should know exist, but aren't something you need to worry about just yet. The first is subqueries. Subqueries are a SQL query inside of another SQL query. It's basically a query that produces a value or table that the other query uses to get its result. CTEs are similar. A CTE, or common table expression, is a temporary set of results that you define at the top of your query so you can use it multiple times later. It helps to break up a complex query into clean, more readable steps. Think of it like this. A subquery is an inline query, while a CTE is a named reusable block to structure the same logic. Both are valid, and you'll end up using both in your queries, sometimes the same query, depending on the circumstances. Then there are window functions. Window functions let you perform calculations across a set of rows while still keeping the individual rows in the result. So for example, if you wanted to include a running total or a moving average inside each row, you'd use a window function. But as I said, at the junior level, knowing these exist is enough. You don't want to add too much complexity too soon. Make sure you get the fundamentals down first. Remember, in the real world, SQL is rarely used by itself. Most of the time, SQL is feeding something else: Excel, Tableau, Power BI, whatever. SQL gets the data into the right shape, and then the actual analysis happens someplace downstream. In your first data analyst job, you won't be writing complex queries from scratch anyway. In most roles, you'll spend more time reading and modifying existing queries than building brand new ones. It's normal, and honestly, that's where you learn the fastest. This is why judgment matters more than syntax. You need to understand what the query is doing and whether it actually answers the business question being asked. Because at the end of the day, your job isn't to write SQL queries. It's to answer business questions. SQL is just a tool to get you there.